So how do you know so certainly that it's going to miss us?
We know that because we've actually been able to track this one reasonably well because it came very close to the Earth 1 year ago when we discovered it.
All right.
And that's the key. Right now, we can only track asteroids accurately when they come pretty close to the Earth, um, uh, with some caveats. They have to come close to the Earth on the dark side of the Earth because our telescopes don't work really well pointing at the sun. And because asteroids are dark, and anybody who's ever been out on a full moonlit night knows it's tough to see stars when the moon is out there. So asteroids that come really close to the Earth on the dark side of the Earth when the moon isn't full is when we pick up asteroids right now. And this one luckily did last year, and that's how we found it. And we're actually really good. NASA has developed an unbelievable ability to calculate orbits of things. I mean, you know this, Ron, right? When we did rendezvous. But even more amazing than some of the rendezvous, that we used to do are the kinds of things that JPL does, right? We landed Curiosity in a target zone just to one side of a mountain in the middle of a crater on Mars, right? And remember that was planned out years before they ever launched the thing, right? So we can track where things are going. We can even target where things are going, and use our precision tracking to adjust trajectories to get to where we want to get to. And that means we can, if one of these asteroids comes close enough for us to spot it, we can track it. And that's what we did here.
So Phil, have you checked the math?
Especially equation 6.
Yes, yeah. Oh, that one's tricky. When I was an undergrad, we had a homework problem where we had to find an asteroid on a picture just given the characteristics of the orbit of the asteroid. So literally, he handed us a list of, here's how long it takes to go around the sun, here's its distance, and a couple of other things, the shape of its orbit, and a photograph with like 10,000 stars on it, and said, one of these is the asteroid, which one is it? So you have to basically know when the picture was taken, calculate the position of the asteroid, and find it. And it turns out it's really hard to do. And that was mumble years ago. Now we have computers that do that.
That's why we have computers.
Exactly. So the way, for example, this asteroid 2012 DA14 was discovered was a Spanish observatory was observing the sky, and they saw this thing moving, and they calculated exactly where it was on the sky, knowing where the stars were on their in their observation and when they took the observation. And as this thing moves, the way it moves depends on its distance from the sun and the Earth, the shape of its orbit, for example, if it's very circular or very elliptical, how that orbit is rotated around the sun like that, how it's tipped and tilted, all of these things go into determining where the asteroid is going to be in the future. But the most important thing is knowing exactly where it is in your observations. And any little error you make, and by error I don't mean mistake, I mean you just can't exactly get the exact
position. Size of your pixels, right?
Yeah, I mean, yeah, if this object is small, which asteroids are, and you have big pixels on the sky, you don't know its position very well. And even if you have small pixels, it's hard to get exactly the position of this
No
thing.
matter what, your pixels aren't zero.
That's right. And there's other problems with the Earth's atmosphere blurring it, your camera not being perfectly square. There's actually a little bit of distortion in there. All of these uncertainties multiply over time. The farther in advance you try to predict where this thing is, the worse your prediction gets. Well, doing all this, last year, they were able to determine that this asteroid would pass the Earth basically Friday on February 15th. And we knew it was going to miss us by about 17,000 miles. And as a matter of fact, that turned out to be pretty accurate. And as we're getting more observations of this thing, we're getting better and better orbits. We know it's not going to hit, but exactly how far it's going to miss us, whether it's 17,100 miles or 16,900 miles, that's still being determined. But it is absolutely going to miss, and this is a great opportunity for us to observe this thing, figure out how to get multiple telescopes on it, get its distance, refine its orbit, get practice doing this so that if we do see one that's not going to miss, we can figure it out as far in advance as possible.
It's also a good chance to just sit back and be amazed at people's ability to calculate these things. It's really kind of wonderful if you think about it. Everything that goes into doing these things with such precision. Even though I've been living this world for 20 years, it never ceases to amaze me.
I do want to say that DA14, this rock that'll pass us on Friday, some people are scared about it. You don't need to be. It's going to miss us. And as a matter of fact, we know its orbit well enough to know that it's not going to be a threat for quite some time, decades at least. This is not a bad thing. This is a good thing. We discovered it. We discovered it a year in advance. We had a lot of telescopes on it. We're learning all about it. That's great. The cautionary tale here is that we only learned about this thing a year in advance. It's passing us 17,000 miles above the Earth's surface. That is the distance the Earth travels around the sun in about 15 minutes. Now, this particular asteroid is kind of coming up underneath the Earth and going around. It's not like if it had been 15 minutes later, we would have hit it. It would have missed anyway. The point is, 17,000 miles is a pretty close shave, and it could have just as easily hit us as been 17,000 miles farther away. The point is, these things are out there. They do come close to us every few years. They do impact us every few decades, every few centuries, whatever number it is. We need to be looking at them. The DA14, I'm glad this is getting to publicity. It's a wake-up call that there are rocks out there. They come close. We need to be looking for them. And we also, at the same time, need to be thinking very carefully about what to do if we see one that's headed right at us at some time in the future.